All right, here we are, Chapter 3, Lesson 4, Plate Boundaries, the first day. Let's set up our paper, our name, class, AVID 6, date for this video, it's Monday, November 9th, 2020. Topic or objective, science, FNT, Phase 3, connect. Chapter 3, Lesson 4, Plate Boundaries, capital P-L-A-T-E, capital B-O-U-N-D-A-R-I-E-S. Plate boundaries. Main idea or essential question. Now we're going to be going fast, okay? Because this is a short week from Veterans Day. We're going to have to do day 1, day 2. Day 3 is going to be the notes and the phase 2 processing, highlighting, annotating for key details to support the main idea. And probably also writing the I know, I wonder sentences. That way the last day we can work on putting this stuff in our e-binder and work on the paragraph together. This will be the last time that I write the paragraph for you. Main idea. Movement along plate boundaries causes geologic events such as earthquakes, volcanic eruptions, and mountain building. Okay, so movement, M-O-V-E-M-E-N-T, on, O-N, plate, P-L-A-T-E, boundaries, B-O-U-N-D-A-R-I-E-S, arrow for causes, geologic, G-O-G-E-O-L-O-G-I-C, events, E-V-E-N-T-S, equals, E/Q, that's going to be earthquake, zoop, VOLC period, that's going to be volcanoes, zoop, MTN period, that's going to be mountain building, BUILDING. So movement on the plate boundaries causes geologic events including earthquakes, volcanoes, or volcanic eruptions, and mountain building. Vocabulary, only one term, subduction, S-U-B-D-U-C-T-I-O-N, subduction. There's the word, go backwards. This process is called subduction. Okay, what process? Keep going backwards. The upper plate forces the edge of the lower plate under the surface. Oh, okay. This upper plate forces the edge of the lower plate under the surface. Okay, so upper plate forces edge of lower plate under. Upper, U-P-P-E-R. Notice I've already folded the paper in half. Upper plate, P-L-A-T-E, forces, F-O-R-C-E-S, edge, E-D-G-E, of, indent, lower, L-O-W-E-R, plate, P-L-A-T-E. Upper plate forces edge of lower plate under, U-N-D-E-R. And of course, what are we going to do? Draw a picture. So let's try to draw something kind of similar to that. So let's see here. Let's have, there's a plate, and we'll put a little dot so we kind of remind ourselves that's the edge. Here's another plate coming in, and draw an arrow. Remember, way out here somewhere is the mid, M-I-D, dash ocean, O-C-E-A-N, ridge, R-I-D-G-E. That's where the plates are separating because magma is rising up into the gap. Okay, and then over here we can kind of build our mountains. And so this is where the subduction happens, right here. So let's kind of squeeze this sideways. Subduction, S-U-B-D-U-C-T-I-O-N. And we write it that way so it kind of reminds us, oh, the subduction goes down and in. And then this looks like it's called a trench. T-R-E-N-C-H, trench. All right, red pen, red pencil, red crayon, plate interactions. Capital P, L, A, T, E, capital I, N, T, E, R, A, C, T, I, O, N, S. Interactions, plate interactions. In other words, how do the plates interact, or how do they hit each other? How do they work with each other? How do they interact with each other? Switch back to pencil. As you have learned, tectonic plates move very slowly. Typically, this motion can hardly be felt, but at times it can cause sudden and unexpected changes to Earth's surface. Okay, so move, M-O-V-E, very, V-E-R-Y, slowly, S-L-O-W-L-Y, indent, can, C-A-N, cause, C-A-U-S-E, sudden, S-U-D-D-E-N, change, C-H-A-N-G-E. I bet you those sudden changes are going to be things like earthquakes, volcanoes, maybe not the mountain building so much, that takes a long time. Why do some regions of the world experience violent volcanic eruptions and devastating earthquakes, while other regions do not? The answer lies at the edges, or boundaries, of Earth's tectonic plates. Where tectonic plates meet edge to edge, movement and interactions produce earthquakes, volcanoes, and other geologic events and structures. Okay, so the edges or boundaries where the plates meet is where all the action is. Okay, let's see. Movement, M-O-V-E, M-E-N-T, and down 3 down. Interaction, I-N-T-E-R-A-C-T-I-O-N, at the letter A and then circle it. Indent, boundaries, B-O-U-N-D-A-R-I-E-S, slash, edges, E-D-G-E-S. So there's movement and interaction at the boundaries or edges. Okay. We know it produces earthquakes, volcanoes, and other events. So arrow, come down, stay indented, earthquakes, E/Q, volcanoes, VOLC, period. Let's see, other events and structures. Let's just put ETC, period, for etc., which means others like that, earthquakes, volcanoes, etc. All right, types of plate boundaries, red pen, red pencil, red crayon. Skip one line just in case. Capital T-Y-P-E-S of plate, capital P-L-A-T-E, boundaries, capital B-O-U-N-D-A-R-I-E-S. Switch back to the pencil. There are 3 types of plate boundaries: convergent, divergent, and transform fault. Okay, that's important. And there's 3 pictures. Guess what we're going to do? Draw 3 pictures. Okay, let's do it in the same order that they do it in. Let's put transform fault on the left. So T-R-A-N-S-F-O-R-M, fault, F-A-U-L-T. Okay, so transform, well, hey, that's like a transformer, something that changes. A fault, we remember that faults are the cracks in the ground. We learned that in a previous lesson. Okay, let's go right around here in the middle. Divergent, D-I-V-E-R-G-E-N-T. Divergent means things diverge or move apart from each other. Convergent, C-O-N-V-E-R-G-E-N-T. When things converge, they come together. So transform is changing, divergent is going apart, and convergent is coming together. And we see that in our pictures. Okay, for transform fault boundary, let's just go ahead and draw like these 2 little boxes next to each other. And actually, let's do like they do, where the one on the left sticks out and the one on the right goes back in. Okay, so we draw like a little rectangle. This rectangle goes further up that way to the top right. Straight lines down straight lines down, straight line down, and then this line is going to be parallel to that line, which is also parallel to that line. That's how they kind of end up looking the same. Then we get rid of that little ghost right there, and there we go. Now this one is moving that way, and that one is moving up to the right. So by using our angled lines all at the same angle and our straight up and down lines, we can kind of make it look three-dimensional. Okay, divergent is coming apart. Let's kind of make that little gap like they have there. I'm just going to put a side view like this and a side view like that. Draw an arrow to the left and an arrow to the right. And then convergent. Notice they show the little subduction happening. So let's go ahead and draw that. Let's draw the curved one going down, and then that bottom part comes back up. And then up here, let's go ahead and draw it like that. And then let's draw the arrow going down and in, and the arrow coming in that way. And now we remember that's the subduction. And then that means that this is the trench. Let's go ahead and label those. S-U-B-D-U-C-T-I-O-N. Trench, T-R-E-N-C-H. Right here is the fault, F-A-U-L-T. And right along that part right there, that's the fault, F-A-U-L-T. So transform fault means they're sliding past each other, or transforming or changing the fault, the crack. Divergent means that they're moving apart, and convergent means that they're coming together, causing a trench because of the subduction. Okay. Each has characteristic features and causes different events and landforms. Ah, different events and landforms. Okay. At converging boundaries, two plates converge or move toward each other. Eventually, they collide. Okay, we see that in our picture. When plates collide, one may ride up over the other. All right, we see that happening there. We also see that happening here. Where was it? The upper plate forces the edge of the lower plate under the surface. This process is called subduction. Okay, we have that here, 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 and here. So 4 times. We should know that by now. Curve of forgetting. At diverging boundaries, two plates move away or diverge from each other. Molten rock rises up the gap between the plates, forming new crust. Molten rock rises up into the gap. Oh, okay. So that's going to be magma under the ground or lava above the ground. And let's kind of draw a little volcano. So there's a little line, a hole at the top, and a little line. That's going to be our volcano. That's how rift valleys form. Oh, wait a second, yeah. Okay, not a volcano. Get rid of that little volcano. Get rid of the word lava because it's taking up space. Let's write that. Rift. R-I-F-T. Valley. We ran out of space, so let's just do rift. R-I-F-T. A rift or a tear or an opening, a valley. All right, what else? This usually happens along mid-ocean ridges. Okay, so we're used to that happening over here. We're used to this being a rift. This usually happens along mid-ocean ridges. As you have learned, the process is called sea-floor spreading. At transform fault boundaries, plates slide horizontally past each other. Horizontally, or the horizon, right? The horizon is the left to right flat part of the world. So horizontal means they're moving flat left and right. Crust is not created or destroyed. Instead, it is buckled and deformed. Okay, so let's see. Under divergent, we get new crust, C-R-U-S-T. But convergent, we are actually destroying crust, D-E-S-T-R-O-Y, crust, C-R-U-S-T. And here at the transform, it just buckles, B-U-C-K-L-E-S, which means it's bending or changing or folding. Deform, D-E-F-O-R-M. Okay, so that kind of makes sense and connects to what we learned last lesson. Sometimes new crust is created, sometimes crust is destroyed. That's how there's a balance between the two. And for transform faults, it's just changing shape, buckling, folding, deforming, and bending. Whether they are converging, diverging, or sliding past one another, Earth's plates never stop moving and changing. New rock is added to Earth's crust in some places, while old rock is lost to the mantle in other places. Okay, let's look at our pictures. We have those. Looking at this picture, we don't want to draw the entire thing, but we know that the ridge is the spreading, and that creates rifts. Our new thing that we're learning is about subducting plates, where the continental crust is forcing down the edge of the oceanic crust, creating a trench. And then we also know that rift valleys can form, but very rarely on the continent. Okay, Mauna Loa, Hawaii. So Hawaii is a very famous volcano, and it kind of looks like these islands. Basically what happens is all this stuff gets forced underneath. All this pressure causes a lot of heat, which causes the rock to melt and turn into magma, and it rises, and eventually it can explode out the top in a volcano. Over here, Yellowstone National Park. Same thing over here. As this plate is going down underneath, all that heat and pressure and friction causes the rock to melt into magma. If it gets hot enough, it's lava and explodes out in volcanoes. And then in places near that, underneath the ground, it can be very hot. Hot enough to make water boil. All right, any other pictures? Nope, cause and effect. Why do only some areas experience volcanic eruptions? Okay, only some areas experience volcanic eruptions because the movement and interaction is only happening at plate boundaries or edges. So for example, sometimes you're only getting buckling and deforming at transform faults. Sometimes you're getting new crust forming at divergent boundaries. And sometimes you're losing crust to the mantle at a subduction. And this also builds mountains. So let's draw some mountains up here. Okay, we get mountains. All right, I think that's it for this day. Good job persevering with the growth mindset. Roar Wildcats.